Hi everyone. In this section of our lesson, we'll be learning about the test for cations. The test for cations is actually quite a big section, so we'll most likely be splitting this lesson into two different parts. Okay, so we need to first understand the theory and then after that the observations. Okay, so in the test for cations, we are looking for metal cations, obviously. So qualitative analysis, right, this chemical test is actually one way for us to test for the presence of certain metal cations in our drinking water. And you know, our drinking water contains a lot of ions, and these ions might be too small for us to see, so we actually need to add something into the water such that a precipitate would come out. A precipitate will be formed. And when we see a precipitate, we can confirm that ion is present over there. So the procedure is as such. We can either use sodium hydroxide, either or, though not two at the same time, either sodium hydroxide or you add in aqueous ammonia. So either or. You can add in first dropwise. And when it's added dropwise, it will first form a precipitate. And you need to record down the color of this precipitate. After you have recorded down the color of this precipitate, you need to add the sodium hydroxide or the ammonia again until it is in excess. That means about the test tube about halfway, and then you stir the mixture. And then you need to check whether this precipitate that was originally formed, is it soluble or whether it is insoluble in the excess solution. So what is actually happening? So let's look at this chemical reaction over here. We have iron 2 nitrate, right? And iron 2 nitrate contains the iron 2 ion, and it reacts with the sodium hydroxide. So it will form a precipitate. It will form this precipitate, iron 2 hydroxide. And because we have learned that all hydroxides are insoluble, so therefore this hydroxide, iron 2 hydroxide that forms will be solid. And we'll suddenly see, oh, we can see this iron 2 hydroxide that is formed. And later you'll learn that this iron 2 hydroxide is actually a green color, right? And besides this iron 2 hydroxide that is formed, you will also form sodium nitrate, which is still in the solution, so you can't see it, it doesn't matter, right? But the iron 2 hydroxide, which is a precipitate, is something that you can see and confirm. So how would this look like, right? We have actually the iron 2 ions. Let's write this down. Iron 2 ions in the solution floating around. We add in the sodium hydroxide or the aqueous ammonia, which are both alkaline. So they have OH minus ions floating around too. And when these Fe2 plus ions and OH minus ions float around and they meet each other, it will form that precipitate, the iron 2 hydroxide precipitate. And this is your red brown color precipitate, PPT. And this is how we actually observe, right, the test for certain cations in our water. So this is because, as you can see over here, that all hydroxides are insoluble except your spa hydroxides, your barium hydroxide, and your calcium hydroxide, which is actually partially soluble. So this method cannot be used to identify spa hydroxides, spa ions, we cannot test whether there's sodium or potassium ion in our water using this method, and we cannot use it to test barium ions in our water. Okay, so I will go through some of the observations of the reactions with sodium hydroxide first. Okay, so when we add sodium hydroxide to copper 2 ions, we will actually get copper 2 hydroxide. Okay, copper 2 hydroxide, and this copper 2 hydroxide is a light blue in color. So we must know that this copper 2 hydroxide is a light blue precipitate, and that's very important for us to know, copper 2 hydroxide. When we test, when we add in excess, this copper 2 hydroxide is actually a basic oxide, and therefore basic oxides do not react with more alkali. So this is insoluble in excess because it cannot react with more alkaline, right? Iron 2, you will form iron 2 hydroxide, which is what I mentioned just now. And this is actually our reddish brown or red brown precipitate. And again, iron 2 hydroxide is a basic hydroxide and will not react further with sodium hydroxide, and therefore is also insoluble in excess. Okay, so that means the precipitate form, but when you add more, it doesn't dissolve. Iron 3, oh sorry, this is not reddish, oh no, this is not reddish brown. This should be, can we please change this? This should be green precipitate. Sorry about that, this is green precipitate. And over here, iron 2 should be green also, green precipitate. Because the iron 3 over here, form iron 3 hydroxide, it's like rusting. You know, you have something, the iron, and then when you rust, your rust is a red-brown color. So iron 3 hydroxide is also red-brown color. We can rust it. So the reddish-brown is the reddish-brown PPT. Sorry about that. Make sure you make the change. Iron 2 hydroxide is green. Iron 3 hydroxide is reddish-brown. And again, iron 3 hydroxide is also a basic hydroxide and therefore will not react with excess sodium hydroxides. Now, we come to calcium hydroxide. So calcium, when you test, you get your white precipitate, and this is calcium hydroxide, and this is insoluble in excess, right? And then we have these three. Lead-2, you form a white precipitate, lead-2 hydroxide, aluminium, white precipitate, aluminum hydroxide, and zinc hydroxide, white precipitate. And you realize they are all three white, so it's very hard to identify. But what we must notice is that this tree is your LAZ, and you should have already recognized that this is amphoteric. And because these are amphoteric oxides, hydroxides, it can react with more sodium hydroxide to actually form, right, a colorless solution. So all three of them are actually soluble in excess to give a colorless solution. Colorless solution. And also the same for zinc ion, soluble in excess, right? Because it's amphoteric, right? To give a colorless solution. So then you might be wondering, Mr. Benjamin, my lead ion, aluminum ion, zinc ion, I cannot use this method, right? They are all the same results. I can't tell which one it is. So that's why we have the aqueous ammonia, right? So in the next video, we'll be learning more on how we use the aqueous ammonia to actually test further for these ions, right? See you there. Bye.